Okay, so in this video, we're going to be having a look at domain and range. So by the end of this lesson, you'll be able to find a domain and range and write that in a mathematical sentence using inequalities, but also by using interval notation, which we haven't done yet. So in today's lesson, there's a whole bunch of different graphs that you should be familiar with by now. And be able to write the domain and range for each of them in both inequalities and in interval notation. So just to refresh your memories, domain and range, the domain refers to the set of possible input values. The domain of a graph consists of all the input values shown on the x-axis, and the range is the set of possible output values which are shown on the y-axis. Okay, so interval notation, you are probably not familiar with this. An interval is a connected subset of the real number line. So in interval notation, an interval is specified by an ordered pair of numbers consisting of the left and the right endpoints of the interval. Since an interval might or might not contain its endpoints, we use square brackets when endpoints are included in the interval and parentheses when endpoints are not included. So here's an example. So parentheses 0, 1 square bracket represents the interval of all positive numbers that are equal to the number 1. But since 0 is not a positive number, it is not included in the interval, whereas 1 is included since 1 is less than or equal to 1. The entire number line written in interval notation is parentheses negative infinity, infinity, parentheses. So we use parentheses here because the interval can never reach plus or minus infinity. Okay, because infinity is not really a number, it's more of a concept. The set of non-negative numbers is square bracket 0, infinity, parentheses. A subset of the number line consisting of two or more intervals is written using the set union symbol, which is this U. Okay, so for example, the set of all real numbers lying at least 1 unit from 0 but less than 2 units from 0, written in interval notation is parentheses -2, -1 square bracket union square bracket 1, 2 parentheses. Okay, so let's have a look at these examples here. We're pretty familiar with these diagrams, with these inequality graphs. When there's a closed circle, it includes that number, but when it's an open circle, it doesn't include it. So when we write these using the inequalities, this bit here is between x is between 0 and 1, but it includes 0 and 1, that's why it's less than or equal to for both of them. However, x could also be between 2 and 3, inclusive, because they are both closed circles. That's why we've got or 2 is less than or equal to x, which is less than or equal to 3. Okay, so when we use interval notation for this, we have, because it includes 0, we use the square bracket. It includes 1, so we use the square bracket. We do the union symbol. It includes 2, so we use the square bracket. And it includes 3, so we use the square bracket. Okay, let's have a look at the second example. Here we have x is between -1 and 1, but it doesn't include -1 because of the open circle, but it does include 1. That's why here the symbol is just -1 is less than x, but it's less than or equal to 1. Okay, so when we draw this out using interval notation, we have a curved bracket. I'm just going to say curved bracket instead of parentheses. We have a curved bracket. -1, comma, 1, but it includes +1, so we use a square bracket. Union, okay, or, okay, union just means or. And here we have x is between 3 and 6. It includes 3, but not 6. So because it includes 3, I'm going to use a square bracket. 3, comma 6 doesn't include 6, so curved bracket. Okay, have a go with the next one yourself. Pause the video and then you can check your answer. Okay, so for the last one, it's from -infinity, and because it can't include -infinity, we use a curved bracket, comma 2. It includes the 2 because it's a closed circle, so we use a square bracket. Or x could be between 3, but it doesn't include the 3, and 4, but it doesn't include the 4. Okay. Alright, the notation, square bracket a, comma a, closed square bracket, is the one member set, a called a degenerate interval. That's just a brace. Okay, so this symbol is a brace. An interval is called closed if it contains all its endpoints and open if it doesn't contain any of its endpoints. Okay, so let's have a look at this one. Now we're going to have a look at a whole bunch of different examples. We're going to state the type or name of the graph, the domain and range in either using inequalities or elements of all real numbers using set notation, as well as with interval notation. So here we've got question A, y equals 2x minus 1. We know that the power of x is 1, so it's just a straight line. Okay, so it's linear. Okay, part 2. If we were to draw this, it'll look something like this, okay, which means it's all real x, okay, or x is an element of all real numbers, and the range is also all real y, or y is an element of all real numbers, and therefore the domain, we can say, is from -infinity to infinity. And the range is also from -infinity to infinity. Okay, remember, whenever we have infinity or -infinity, we use the curved brackets. Okay, question B, y equals 4. Might be best to always just graph it first to see what you think it will look like. Y equals 4 is probably around here. Okay, straight line. So we know this is linear. Here's a horizontal line. Part 2, the domain. X is an element of all real numbers. And the range, however, is just y equals 4. Okay, y doesn't change at all. It's just 4. So when we write this in interval notation, we can say because the domain is x is an element of all real numbers, it goes from -infinity to infinity. The range, however, is for a square bracket 4, comma 4 square bracket. Okay, because it includes 4. It's only 4. Alright. Let's have a look at question C. So here we have a problem. Okay, we know that it's just y equals x squared shifted down 1 to -1. So part 1, parabola. The domain is all real x, or x is an element of all real numbers. And the range is y is greater than or equal to -1. Okay, because it never ever goes down past -1. So y is greater than or equal to -1. So what does that look like in interval notation? X is an element of all real numbers, so the domain is from negative infinity to infinity. Range, however, because it includes -1, we use the square bracket, and it goes all the way to infinity, but curves bracket. Okay. Question D, we've got y equals 2x squared minus 6x plus 8. Because the highest power of x is 2, we know it's a parabola. So, part 1, parabola. Okay, to determine, because we know there's going to be a parabola, we just need to work out what the turning point is or what the vertex is. So, if I were to work out the x-coordinate using x is equal to minus b over 2a, well, if b is minus 6, minus b is positive 6. If a is 2, 2a is 4. So the x-coordinate is 3 over 2. Therefore, the y-coordinate, we're just going to substitute this back into the original equation. 2 lots of 3 over 2 squared minus 6 lots of 3 over 2 plus 8. Okay, and when we put that in our calculator, we will get 7 over 2. And we need this for the range. Okay, so if we have 3 over 2 here, we have 7 over 2 over here. So our parabola is going to look something like that. Okay, so because it's a parabola, domain x is an element of all real numbers. Range, y is greater than or equal to 7 over 2. How do we rewrite this in interval notation? Well, x is from negative infinity to infinity. And the range is, well, it includes 7 over 2 because of this or equal to it. So we're going to use square brackets, comma, and it's greater than that, it goes all the way to infinity. And sorry, that's a curved bracket. Okay. Have a go with question E yourselves. It's very similar to D, so I'll get you to pause the video. And when you're ready to check your answer, I'll get you to check it. Okay, so here's the answer. It's a parabola, and it's concave down because it's negative x squared. So here we use the vertex x is equal to minus b over 2a. Be careful with this, because minus b is this one. So b is minus 2, so negative b is positive 2. And a is actually the coefficient of x squared. Okay, so it's not that 3. So domain x is an element of all real numbers. Range y is less than or equal to 4. Okay, because when we've substituted the x-coordinate of -1 into the equation, we get a y value of 4. And we know it's a maximum because it's concave down. Okay, so the y has to be less than or equal to 4. Alright, question F. We know that this is a cubic. And because it's positive x cubed, it's going to be shaped like this. Therefore, the domain is x is an element of all real numbers. Range y is an element of all real numbers. And therefore, this is from negative infinity to infinity, as is the range. Now, I think it's very important for you to know that whenever the degree of the polynomial, or the highest power, as long as the polynomial is odd, it's going to be looking like this if the coefficient of x, of the leading coefficient is is positive, it'll be shaped like that. If it's negative, it's going to be shaped like that. But it doesn't matter because either way, the domain and range will always be from negative infinity to infinity. Okay, so there's nothing limiting how far x is or how far y goes. Okay. All right. Let's go with question G and H. I'm going to get you to pause the video, have a go yourselves, and then when you're ready, you can check the answers. Okay, so as you can see here, both G and H are cubic, and therefore the domain and range, they both go from negative infinity to infinity. All right, let's have a look at 2 more questions, and then I might create another video because this one's getting a bit long. So question I, we have negative x minus 1, x minus 2, x minus 3. So we can tell here when we expand this, we're going to have x cubed, but it's going to be negative x cubed. So we know it's going to be a cubic, but we also know it's going to be shaped this way. Okay, because it's negative x cubed. Which means that domain is x is an element of all real numbers. The range is y is an element of all real numbers. And therefore when we write this in interval notation, it's from negative infinity to infinity for both. Okay, so for question J, we have y equals x minus 1 all squared, x minus 2, x minus 3 all cubed. And so when we expand this out, we've got 2x's 3 plus 3 is 6. So technically when we expand it, it's going to be x to the power 6, etc. Which is an even degree. Which means it's going to be a parabola. It's going to be concave up parabola. But of course it's going to be a bumpy one. So it might be something like this. Okay. Alright. Now, this is called a sextic polynomial. Okay, because the power of x, the highest power of x is 6. So the domain of this, we can see x can be anything. So actually, let's write this. Domain x is an element of all real numbers. However, the range, we need to know what the lowest point is. I don't know whether it looks like this or not, but we're going to use Desmos to do this because we haven't actually learned how to do this yet. We will do that later in the year. For now, we're just concerned about what the graph looks like. So if we were to put that into Desmos, we would get this. The lowest y value we can see is here, which is negative 0.176. So it's negative 0.176. Therefore, the range has to be that y is greater than or equal to negative 0.176. Okay, because all of these y's, all of these values are larger than that point. Okay. So when we write this in interval notation, domain from negative infinity to infinity, range is from negative 0.176, but it includes it, that's why we have a square bracket, all the way to infinity with a curved bracket. Alright, I'm going to end this video here. I'll make another one or maybe another 2 because there are a lot of examples to go through. For now, I'll just get you to watch the next video.